Hi everyone and welcome to the exam walkthrough video for the CS61A Fall 2021 final. And yeah, let's just get into it. So I guess I'll just fill these out for completion. So my name's Michael. I'm not gonna put my student ID then. Okay. Yeah, this was actually the final that I took when I was a student in 61A, so doing this again will be especially fun. But yeah, so problem 1A is House Atreides, and it looks like it's just going to be a fairly straightforward environment diagram question where they give us the code and we essentially have to fill out the blanks inside the environment diagram that they've given. Now, to be honest, whenever I get these problems where they've already provided like a structure for the environment diagram, I found that the structure is not really helpful because in order to get the answers, you have to walk through every line of code anyways. So what I usually do is just do the entire problem without the skeleton on like a piece of scratch paper or something, which is why I'm making a new page here and just pasting the code. Okay. Yeah, because I find that the structure is just kind of gets in the way in the beginning when you don't really know what the code is going to look like until you really walk through everything. And then after you have the answers, you can use the structure as like just a sanity check to make sure that what you've done is correct so far. Cool, so let's just dive into this problem without any skeleton. So in order to make an environment diagram, you have two kind of columns. You have your frames and you have your objects. And the first frame is always going to be the global frame, and that's kind of your environment diagram skeleton. So in our global frame, looks like we're defining three things. We're defining Gurney, Paul, and Cheney. So let's erase these marks, but we have Gurney, which is going to be a list containing 1 and 2. Then we have Paul, which is just going to be some function. Paul takes in Lido, and its parent is global. And then we have Cheney. It's another function that takes in Paul. And its parent is also global. Yeah, so a lot of this solving environment diagrams is kind of a tedious process, but it's just essentially following a strict set of rules. So as long as you're really careful with the steps that you make, you shouldn't make any mistakes. Okay, so just remember, we don't actually step into any of these def statements until we actually call the function, which is why I've just drawn out arrows to Paul and Cheney. So in this bottom line is when we finally call Paul. So this means that we have to open a new frame, so F1, and the frame is going to be Paul, and parent is again global. So now the first thing we do when we open up a new frame is to define what the formal parameters are. So Paul takes in Lido, so Lido is what you're passing in, and what we pass in Lido to be is Gurney, and Gurney we know is going to be this 2-element list, so I'll just draw an arrow wrapping around to Gurney. Cool, so now the next step is to just run through the code of Paul. So it looks like we're defining a new function called Duncan. So Duncan is going to be a new func. Duncan takes in a Gurney. And its parent is going to be now F1 because we've defined the function in F1. Remember, the parent of a function is going to be the frame in which it was defined. Cool. So now we don't step into Duncan yet because we haven't called it. Instead, we move on to the next line, which assigns Gurney to be a new list containing Lido and 4. So Gurney is going to be a new list that is, the second element is going to be 4, and the first element is going to be Lido, which is a pointer to this list. So I'll just copy this pointer all the way around to here. Alright, So now we're on this last line inside Paul, which is a call onto Duncan. So now we have to open another frame for this new function call on Duncan. And remember, Duncan's parent is f1, so p equals f1. And then, again, first step whenever you open a new frame is to see what the formal parameters are. So the formal parameter of Duncan is going to be Gurney. And we're calling Duncan, sorry, that's messy, Gurney. And then we're calling Duncan on the list Gurney, comma 5. So this is actually going to be a new list. Again, 2 elements, the second element's a 5, and the first element is Gurney, which is defined in F2 to be this list. Or sorry, F1. Cool. Okay, now the second step, once you've figured out what your formal parameters are, then you just basically run through the code. So now we're inside Duncan. Okay, so the first line is calling, assigning the 0th index of the 0th index equal to 3. So Gurney's 0 is going to be this arrow here. 0 again is going to be this box here, which currently contains an arrow to Gurney defining the global frame. But now we're just going to assign it to be 3. So we're going to erase this arrow and just replace it with 3. Okay, so now the next line is a call on Cheney. So this is a new function call, which means we have to open a new frame. The frame is named Cheney, and since Cheney was defined in the global frame, the parent is just global. So p equals g. As always, our formal parameters. So the formal parameter of Cheney is going to be Paul, but we're calling it on Gurney. So the input of Paul is actually going to be Gurney, which is right here. Yeah, and again, it's this Gurney instead of the Gurney defined in the global frame because we called it, we called Cheney inside F2. So that Gurney inside F2 is the one that we looked at first. Okay. Oh, sorry, I just realized that this was cut off. So, sorry, hopefully you guys could kind of, I guess, imagine what I was writing while I walk through that. And now you can see, like, just to make sure this is what you should have gotten up until now. So now we finished evaluating, we just started evaluating Cheney. So we finished figuring out what the formal parameter of Cheney is, and now we just need to run through these 3 lines. Yeah, I'll try to keep it dragged here so we can see the instructions, but also as much of the work as possible. Okay, so we're saying Gurney of 0 has to equal 6. Now, which Gurney are we referring to now? Well, we're inside F3, and we don't have a Gurney in here, so we look into our parent frame, which is global. So we look in the Gurney inside the global frame, and then we go into the first index, which is, or 0th index, which is 1. Oops. And then we replace it with a 6. So this 1 turns into a 6. Now the second line goes into the 0th index of Paul, which is right here, and then we go into the first index of that, and we assign it to be 7. So Paul of 0 is this arrow, and then the first element is going to be a 7. So this element should be a 7. So place 4 with 7. There you go. Okay, the last line is replacing Paul, the 0th index of Paul, which is currently an arrow into Gurney in F1, but now we want to replace it with just Gurney. And again, since we don't have what Gurney is in our current frame, which is F3, we look into our parent frame, which is global. So then we find the Gurney inside the global frame. So then this arrow should actually point all the way around into here, back to that Gurney list inside the global frame. Okay, sorry, this is like, you can't see all of the work at once, so hopefully I'll just like show the beginning and then show the bottom. This is overall what the entire environment frame diagram should look like, because after we've evaluated Cheney, well, there's no other function calls, so we're basically done with running the program. Okay, so after we have this environment frame or diagram drawn out, now we just have to match the different blanks into their respective elements that we filled out. So A, looks like these are the values, A and B are the values of the list inside Gurney in the global frame, which happen to be 6 and 2. So I'll just write 6 and 2, or I'll just fill it out inside the blanks. So 6 and then 2. C and D are going to be the values of the Gurney list inside F1, which are 3 and 7. So scroll past. So C should be 3 and 4 should be 7. Okay. Blank E is the E and F are going to be the values of the list inside the Gurney of F2. So Gurney of F2 is going to be an arrow pointing to Gurney in global frame and a 5. So E should be an arrow pointing to Gurney in the global frame, which is right here, and 5. Okay, and now we have G and H. So G is Lido inside F1 and H is Paul inside F2. So let's figure out what those are. Lido in F1 is just an arrow to Gurney in the global frame, and Paul in F3 is equal to the Gurney inside F2. So this should be a list or an arrow to Gurney in the global frame here, and this should be an arrow to the list Gurney inside F2, which is right here. Cool. So yeah, that should be everything for this problem. Again, we solved it by first not looking at the skeleton, and then we used the skeleton as a way to kind of check our work. And I find that this method is a lot at least easier for me, because if you try to imagine like running through the code and drawing out all these arrows, you don't know like when you draw and when you already have it drawn out, and you don't know when you have to like replace arrows and stuff like that. So it gets really complicated. I prefer just to draw it out on a scratch paper first and then match it to the original skeleton.